We are going to look at why it matters what you label A, B, and C when you are using the Pythagorean theorem to solve for a missing side in a right triangle. All right, so if you look at these triangles, they look like they're the same triangle. I mean, the numbers are in different locations, but the triangle itself looks the same. Now, what that means is these triangles are not drawn to scale because obviously they are actually not the same lengths. But sometimes problems will try to trick you in that way. I don't want that to happen, so we're going to look at how to solve each of these problems. So the formula for both of these is the exact same. A squared plus B squared equals C squared. The difference is that we have to make sure we're paying attention to where we plug in each number. The first step that you must always do, take the time to look at the triangle and figure out which side is the hypotenuse. The hypotenuse is always the longest side, and it is always across from the right angle. The corner of the right angle will point it out for you. So if you do this, you will know that this is C in this triangle. In the triangle on the right, the C is actually the 8. The A and the B, the legs themselves, it won't matter which one you label which, because in the formula, they're going to add together anyway. So now we have our sides labeled. Let's plug in and see what happens. So on the triangle on the left, 6 is my A, so I'd have 6 squared plus 8 for B, that's squared. I do not know my C, so that stays a variable. Now I'm going to solve this. C is already isolated, so I don't have to worry about anything there. I'm going to focus on the numbers on the left. 6 squared is 36, 8 squared is 64. C squared must stay the same. We don't know what it is yet. Now we just add. 36 plus 64 is 100. My last step is to isolate the variable. I have to undo that squaring by doing the opposite. Square root both sides. Square root of 100 equals 10. So in this triangle, I know that this length, the diagonal here, is a length of 10. Now let's look at the triangle on the right. Here, my A is still 6, so I'm going to put 6 squared for my A squared. But I do not know what B equals, so I have to leave that one as B squared. I do know that C is 8, so I must put in the number for C as 8 squared. Now we're going to do 6 squared again, which we already know is 36. I do not know B, so it must stay a variable, and 8 squared is 64. Notice in this equation the B is not isolated. In the left, the C squared was already by itself, so I could just focus on the numbers. On this side, I have to actually undo that adding 36 in order to get B squared by itself. To undo that, I must do the opposite, so I'm going to subtract 36 from both sides of the equation. On this side, I'm left with B squared. On the right, 64 minus 36 is equal to 28. Now that I have B squared isolated, I can do the same I did on the other side, undo the squaring by square rooting both sides. So I know B equals the square root of 28. Now if I actually put that into a calculator, I would get approximately 5.29. That is a huge difference from what I had for my other answer, which was 10. So as you can see, it really makes a big difference how you label your triangle and making sure that you solve by isolating the variable.